Here we find the volume of the solid obtained by rotating the region bounded by these four curves about the x-axis. The first curve is y equal to secant of x, which is 1 divided by cosine of x. To graph this function, we picked a few points. Minus pi divided by 2, 0. So here we go down to the negative side. Minus pi divided by 2, minus pi. 0, pi divided by 2, pi. So here we have these 5 points. Now cosine of minus pi is minus 1. So 1 divided by minus 1. We have the secant of minus pi is minus 1. Similarly, we can compute the value of cosine of x, where x equal to this. For x equal to minus pi divided by 2, cosine of minus pi divided by 2 is 0. Secant of x is 1 divided by 0, is undefined. So here, at the point x equal to minus pi divided by 2, secant of x is undefined. And that's why we have this asymptote here. At the point x equal to minus pi divided by 2, we have this asymptote. For x equal to 0, we have cosine of 0 is 1. Secant is 1 divided by 1, which is 1. Here we have this point. Similarly, we can find the values of cosine of x, where x equal to pi divided by 2 is 0. So we have secant of x, where x equal to pi divided by 2 is undefined. So at this point, we also have this asymptote. The function cosine of x, the graph look like this. For the reciprocal 1 divided by cosine of x, the secant function, we have this asymptote here when x tends to minus pi divided by 2 and x tends to minus pi divided by 2. So the function secant of x look like this. And we only need to care about x between minus 1 and 1. So in this region, together with the other curve y equal to 1, which is this horizontal line, secant of x between minus 1 and 1. So the region we have is the region bounded by this purple curve, the green curve, and the blue curve. So the region we have is this region. Now we need to revolve this region about the x-axis. So by revolving this region about x-axis, what we get is this solid. So imagine we have this part, here's 1 and minus 1, so it's empty here. In this part is empty, and then we have this curve which gives us this circle here. So what we have is this solid where we have the hollow part inside here. So here's the solid, we need to compute the volume. And we will use the washer methods. For the disc washer methods, we need to slide the solid perpendicular to the axis of revolution. In our case, we slide perpendicular to the x-axis. By doing so, we create a partition of this segment minus 1 to 1. Each of these segments of length delta x. When delta x tends to 0, we have dx. each cross section is a washer. So one cross section is, we cut this solid by this plane, and one cross section look like this washer. The outer radius of the washer is the distance from the outer curve, which is this purple curve, to the axis of revolution. So outer radius is this length. The inner radius is the distance from the point in the inner curve to the axis of revolution. In our case, it is this length. This length is a constant for x between -1 and 1. Because this is a horizontal line, the distance of point on the horizontal line y equal to 1 to the x-axis is 1. So inner radius is always 1. The outer radius is this length, which is this, the distance from this point to this axis. So assume that this point has a coordinate x, y. Then the length, the point here from 0 to y, give us the outer radius. And in our case, y equal to secant of x. So the outer radius is the secant of x. Inner radius is 1. We can compute the area of the base, which is pi outer radius square minus pi inner radius square. So this is pi secant square of x minus 1. So we have the area of the base. Now we can compute the volume of a thin slice, which is the area of the base times the height. The area of the base is this one, and the height is delta x, and we want the slice as thin as possible, so delta x tends to 0, we have dx. This is the volume of one thin slice. To take the sum of infinitely many thin slices, we have the volume of the solid. So here the solid is, here the solids correspond to x run between -1 and 1. So we take the interval from -1 to 1 of this quantity. So this gives us the formula of the volume of this solid, and by doing computation we get this, by doing computation we get this volume.